So welcome everybody, and thank you for joining Network Partners for this Branch and Learn web event, Worst Case Assessment, Sterile Barrier Systems. A quick few housekeeping items. We ask that you address all your questions through the Q&A feature of this platform. The webinar is recorded, and you will receive the recorded presentation as well as the PDF version of the PowerPoint and a white paper resource on the completion of this webinar. So without further ado, Network Partners' Senior Director of Packaging Engineering, Elon Goldbaum.
Hi, everybody. Good morning, good afternoon to everybody. Thanks, Renee. Today we'll be talking about worst case assessments for sterile barrier packaging systems, so I appreciate you taking the time out of your day. Before we begin, I'd like to give a shout out to Elizabeth Nelson, a principal packaging engineer that works for Network Partners. She wrote the white paper that this is based off of, so kudos to Liz. So let's go ahead and get started. We'll go through some background, some regulations, get some alignment on terminology, go through some worst case assessments, generating worst case assessment scenarios, and then just some reference documents that I pulled all this information from so you can look at it when you get the slides, and then Q&A afterwards. So just quick brief background about me. This slide conveys two things: that I have about 20 years plus experience in the medical device arena, and that you can buy a $50 bathrobe that looks like a suit and take a halfway decent picture. Most of my background is in packaging, CAPA systems, quality systems, and labeling, project management, microbiology. So let's get to it with the regulations. As you know, so as us as packaging engineers, we follow ISO 11607. We'll focus on part one, and we're working with 2019 since that's the latest and greatest. So a couple sections in here. So you'll see the terminology worst case throughout all the standards. And really what the requirements are is, for performance testing, you need to be conducting your packaging systems comprised of worst case sterile barrier systems as well as protective packaging. And I'll get more into some examples of what that looks like throughout this presentation. The other piece of it, which is fairly new, is usability evaluation aseptic presentation. And what this is really conveying is you don't really need to test everything, but you have to group everything by product families, which is where you come up with your worst case scenario, your worst case justification for that, and all those considerations that relate to that. And I'll show you more what that looks like. The other one, as we all know, like ISO 11607 Part 2 for process validations. We have some examples of this, but when similar preformed sterile barrier systems are used for your manufacturing processes, you can create a worst case scenario or justification so you don't have to test everything. But it's up to us as engineers to figure out the best way to author that justification. And I'll show you what that looks like as well. I have a couple examples at the end of this presentation. So let's get some alignment and some terminology here. So a few things. So sterile barrier systems, we all know, and this comes out of the ISO guidance document, minimum package that prevents the ingress of microorganisms that allows aseptic presentation of the product at point of use. And you'll see the terminology point of use throughout, meaning, through your performance testing, through stability testing, so your T=0 testing, and your shelf life, accelerated and real-time aging. And then protective packaging. So, if you look at the picture below, protective packaging are materials designed to prevent damage to the sterile barrier system. So you can consider that like your corrugated shipper, takes the brunt of the forces during distribution. Even down to your carton could be considered much of a dust cover to protect the package. But again, it's all considered combined into that packaging system, which compromises the protective packaging and the sterile barrier system. So worst case assessments, why are they really critical to us? Why are we here listening to me speak on it? I believe it's Thursday morning, but every day feels like a Monday. So for us, really, it's important because it demonstrates the ability of the sterile barrier system, or the SPS, to maintain that integrity under anticipated worst case conditions. And I have some examples of that throughout this presentation. It also challenges all this hard work that we're doing, putting it into our design and development work, utilizing worst case attributes while maintaining a low level of safety and efficacy to the end user. Because at the end of the day, we want to make sure that we challenge our designs and that we can fully commit to, by the time it gets to the end user through all this testing, it's going to be safe and effective for them and no patient harm. Also, it minimizes the amount of resources, meaning, time, people, money required for package verification testing, stability testing, customer design validation requirements from that standpoint. So that would be your usability aseptic presentation, as well as your process validations like your IQ, OQ, PQ with the sealing equipment and the material that you pick. This also is very important. It satisfies ISO 11607 requirements. So that's the big one there. And then I really highlighted audits because I can tell you through 20 years, I've been in so many audit situations where they're like, show me the justification why you picked this product family or this device as a challenging content, over other ones. And really, for us as packaging engineers, we have to demonstrate that and document that in our protocols and reports. Also helps to include pictures of that so the auditor can see that. So I've been challenged numerous times on this without issue, but it's still, these things do pop up from time to time. So let's get into it. Worst case configuration for medical devices. So this one's strictly going to focus on the med device. What do we want to do, right? So here, medical devices that are similar but different. That could mean same product family. Let's say you have a catheter, there are 4 different sizes, 23 to 29 millimeter. Slight differences, smallest to largest diameters. Device lengths could be different based on the diameter. Even the contact points, there could be more or less contact points in relation to the sterile barrier system. It identifies devices that applies the most stress to your packaging, and it's essentially your sterile barrier system, because at the end of the day, we go through all this wonderful testing, we spend all these multiple thousands of dollars to make sure that we can prove out safety and through that sterility. And we also want to use the most challenging contents. I've had a lot of those in my career. One of them I like to call is the bowling ball with spikes. I was lucky enough as a senior engineer to pick a film-to-film ice film header bag. It's like a 7-layer nylon film bag that I thought would be strong enough to maintain this, because we had very little time to validate it. It ended up working over a few times, but it took quite some time to get there. So you want to use the most challenging contents. Utilize common packaging. You could have the same sterile barrier system for the same product families, meaning same material, same seal width, same tieback, the 1073 uncoated 1073D. And then similar protective packaging, right? So you have your corrugated shippers. It could be the same, let's say it's an RSC, it's the same corrugated style, shipper style. Also the carton down to the carton material. Let's say it's 24 point across the board or 26 point. Worst case packaging configuration. So that's the totality of everything together, right? So we're still focused on the medical device on this slide, but we're looking at the heaviest device. We're looking at the devices with the most filaments in the family. So let's say the most touch points. If you're doing a tray that contains, various scissors, blades, that sort of thing, the most filaments there. And it may be necessary to evaluate both of them. So if you can't figure out, what the worst case is, you may have to just create the bookends and challenge the extreme. So it could be the heaviest devices. It could also be the devices with the most filaments and the most components to it. And all other devices would be validated under that rationale under successful completion of your study. So you pick the worst case, most challenging one. And again, this goes back to your resource load, is you don't have to test everything and spend hundreds of thousands of dollars to do this, providing you have the appropriate assessment documented. So worst case configuration when it comes to sterile barrier systems. So similar medical devices use the same packaging system. It basically says a rationale for establishing those similarities and identifying the worst case configuration in your protocol. So I highly recommend pictures worth 1,000 words when you go through and do your justifications. It's helped me numerous times in plenty of audits, because it really gives the auditor an idea of how your thought process is and how you came to develop this worst case assessment. So starting with the sterile barrier system here, and this is really from the supplier. So we're looking at the supplier considerations. First of all, the supplier needs to be qualified through your ASL or supplier quality or approved supplier quality list. And through that, typically what happens is they would do a process validation to characterize the sterile barrier system. And this isn't preformed like a tray, because a tray you would go through a mold qualification. But in this case, I had to do this before when I was a senior engineer. Like we never did it, so I had to go back and qualify about 12 sterile barrier systems across 4 different suppliers within about 4 months. And really, it was doing an OQPQ, reviewing all their data, and making sure that we characterized it. So we had the weakest seal strength. We knew what was the better, and we also understood what the seal width was going to look like to meet our drawings. I'll get more into why we do this later on, because it's super important. And then just some tips here for this is, request the supplier to produce the sterile barrier system under worst case conditions. I've done this numerous times because you're testing the totality of the sterile barrier system, meaning, we tend to focus a lot on our seals, like the medical device manufacturer MDM seals that we create and that we have the process validation for. But sometimes we forget about the supplier seals. It's the whole system that we're responsible for, because once we get those pouches, we create the seals and then we sterilize and start processing it. We are responsible for those. And those, and really qualifying the supplier through an OQP queue, we understand what those sealing process inputs are that create those outputs, which would be your weaker supplier seals. And in addition to that, you want to ask the approved supplier, and I highlighted that because you want to make sure they are an approved supplier, to provide a certificate of compliance or COC certifying that the validated sealing process parameters used to create SBSs produced with weaker supplier seals. I've done this numerous times. What I do is I ask them to cert to it. I take those pouches, I do first articles on them, and then I have them processed so then we can use them for our study and under our protocol. At the end of the day, what I do is with the COC is attach that as objective evidence to my final report, so everything's there. So when it goes through an audit, they can see that we did everything worst case. And then I highlighted this one in red because a wise VP of quality once told me that, if it isn't documented, it never happens. So I think these are words to live by, because we tend to say, well, we make a lot of assumptions. I like to use trust but verify. People come at us with a lot of different information. Go ahead and trust it, but I also recommend just verify it, because a lot of things get lost in translation. So worst case configurations for the sterile barrier system, which will be produced by us or the MDM, any of our clients here. So the sterile barrier system here, when heat sealing, with the sealer, it's important to examine the extremes of the seal area. So for pouches, you're going to look at the small and largest sealed areas. For trays and lids, you would probably look at the totality of the seal under the sealing platen. So that would be the seal width area under that sealing platen there. This approach allows for the impact of oversealing and undersealing. And what this helps us do, and even though it's not very clear in the ISO standard, is when you go through your IQ, you want to understand, you want to thermal map it, you want to pressure map it. There's ways to do this with thermocouples for the heat. And then there's that pressure mapping paper that you can put in there. I've seen this a lot of times on sealers, shuttle sealers, rotary sealers. And what happens is if you put the paper in there and seal it, you can actually see that the lighter the color, the weakest area that's getting either pressure or temperature. So this allows you to understand the distribution of what that looks like when you do your process validation. So it is best practice to do this and really common as well. Utilize your worst case sealing process parameters that equate to a weaker seal strength. So, essentially what this is saying is, before you even do a study, you want to have your process validation under control and really define and characterize what that looks like through a DOE. Understand OQ low doesn't necessarily give you the weakest. It could be the OQ high, but you really have to go through and characterize this to understand this. So when you go into your DV at T equals 0, you know which set of sealing process parameters to use. And I have a tip at the end of this that I like to do, which create a DV low set of parameters, and I'll get more into that toward the end. Also, it ensures the final closure seal is at or beyond the process limit. So meaning if you're sealing windows over here, you're probably going to seal down here, which is your weaker peel strength, and then go ahead and use those as your worst case samples. That takes a water there. Okay, so tips for this. You want to include worst case contents during the sealing process, during the validation, because if the contents affect the geometry of the seal in the process, you want to use that. So it may not be the device itself, it could be the backing card the device is attached to or secured toward, or it could be the tray that goes in the pouch that contacts the seal. You don't know until you go through this. I've been hammered on this by multiple auditors before, and I always write justifications in there and they're always accepted. So these are kind of just watch outs that you want to be mindful of as you go through and you're doing all this wonderful work for your projects. You also want to include the worst case rationale for the contents used. So if you have if you have a family of products and they're all very similar in geometry, or heavier, what I like to do is show pictures in my protocol and then just describe why this is going to be worst case, why this is going to be chosen for this type of process. And then also if you have a multiple tools like a rotary sealer, shuttle sealer, let's say, consider a multiple cavity seal platens qualifying a family of tools. Again, this goes back to resources. You know, if we're typically under as packaging engineers under time constraints and money constraints. So we're not going to test everything in the world, but we want to make sure we have the appropriate assessment to select maybe 1 or 2 tools for this to test. Some additional tips for this under the MDM consideration. So like I said, OQ load does not necessarily equate to weaker seal characteristics, peel strength, maybe minimal seal width, visual along those lines, or burst strength. You'll find that out as you go through and do DOE and your process validation. Your process validation will always determine the set of inputs, meaning your temperature, dwell, and pressure that equate to weaker outputs, meaning your seal strength, your seal width, visual inspections, those sort of things. And what I do, like I said before, is I create a set of DV low sealing parameters through feasibility testing that fall below your validated sealing window. And this has helped me many of times because, you know, as you know, nothing goes perfectly in what we do in our world, but on the manufacturing floor, if you have a validation where your sealing window is over here and something does happen where it goes out of spec or something and it falls below that, and you don't want to scrap the entire load that was just made, then you could look and say, hey, you know what, I validated way below the sealing process. Here's all the data in the test report to say, I feel confident enough that there's going to be no issue because we've proven out through performance testing at the weakest of the weak that you're still going to maintain sterility. And then you kind of go through that whole process to move the product forward. So that helps a lot too. Sealing process, we always have this assumption that our sealing process parameters should be linear. So if your pressure, temperature, and dwell should be the low, 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 and then then you have high, 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 and then in the middle it's going to be really nice and easy. It typically doesn't work out that way. If it does, that's wonderful. But this is where you do your DOE study and you kind of go through that combination of parameters to see what's going to work for you. So it could be a mix of things. It's not typically linear in that sense. And then like I mentioned before, you go through your DOE, you go through your process validations before you create your test samples, and really just prove out your sealing process window there and have everything defined and characterized. All right, and this is where this example here is where I go, what I used to do. It's a very conservative approach here. So this is another tip for your consideration is creating those DV low parameters. And if you look at the way I have this bar set up down here, it goes OQ low, OQ high, and PQ nominal. So I made it very simple, okay? If you look at it this way, your temperature PLC tolerance is plus or minus 5 degrees. And I noticed they use Celsius, and down here it's Fahrenheit, so that's my bad, but I did catch it. So, and then your thermocouple, let's say, is plus or minus 2 degrees Fahrenheit. And what I do with the tolerance stack up is say, okay, well, if this is plus or minus 5, this is plus or minus 2, I'm going to do plus or minus 7. I take a very conservative approach to this because the sealing process is very important. We create that final terminal seal, and we have to prove out safety and efficacy at the end of the day through worst case. So if I'm saying that my nominal is 260, then I'm really just adding this up to say, okay, my OQ high is going to be 267, my OQ low is going to be 253. As you can see, it's plus or minus 7. It's got the tolerance stack up in there. And then what I'd like to do is take it one step further and do a DV low. So if you look over here to the left, there's 246. So I take another 7 degrees below the OQ low. So now I have a really weak worst case, and I highly recommend you do some feasibility testing around this, like a lab notebook study, just to make sure, you put it through some testing to make sure you're not gonna blow open a seal. So it gives you a higher confidence going into your package verification testing there. So this is very helpful, strongly recommend it, and along with the tolerance stack ups as well. Okay, worst case configuration for performance testing. So, out of ISO 11607-1, performance testing allows for verification of how well the sterile barrier system and the packaging system in totality holds up to the rigors of handling, distribution, and transportation. Performance testing evaluated through all the intended processes of worst case sterilization. I'll get into what that looks like. Distribution and storage up into the point of use. So there's that terminology again, up into the point of use, meaning through performance and through stability testing. So let's start with the medical device. So high level here, what are we going to consider? We're going to consider the most challenging contents as it relates to the SBS. It could be like I said, the most filaments, the largest diameter, the longest delivery system. So many things that you have to look at and assess to come up with that. And then you go to the sterile barrier system itself, you know, and you have let's say if you do a preformed with a tray going into a shuttle sealer where you just put the Tyvek lid stock on, you're just going to do a mold qualification on that and probably randomly pick out trays, measure them, and use that for your testing. For the pouch itself, you're going to order them with the supplier, which they're more than happy to do for an extra few, dollars. And they're going to stick to it. They're going to produce them at the low end at their process that they've already validated. So you know that the supplier seals are coming in under worst case. And then you're going to produce yours under worst case. So the whole totality of the pouch, chevron, rails on both sides, and the MDM seal are going to be done at the weakest of the seals there. And then protective packaging. So the heaviest, most challenging packaging and the largest pack factor. So what does that mean? It could mean you're doing a 5-pack. It could mean you're doing a 3-pack or a 1-pack. So that's what you want to do. You want to use the heaviest and the largest. I can tell you back in the day when I was a senior engineer, we had all sorts of packs. It was 1-pack, 2-pack, 6-pack. I think there was an 8-pack. Various products that were used for one surgical use. And what we ended up doing, marketing came up and said, we want to ship these and sell these as a 1-pack, but we don't want to go back and spend all this money to test it. So I had to go through and I did some thinking on this. I used a little bit of physics on it because we had successful validations based on worst case 6-packs, 5-packs, 4-packs. So what I ended up doing was looking at what mathematical formulas for kinetic energy and potential energy as it applies to distribution testing, because you do have the mass, you know what the constant is for gravity, 9.8 meters per second squared, and you can put that into the formula, and it demonstrates that if you've already validated to the worst case, the heaviest, now you're going to move everything to a single pack, and then you just construct the shipper out of the same material, the same style. It's just smaller. So there's no interaction between multiple cartons within the shipper. It's just one carton within one shipper. So that's one way I took a approach for doing it. It seemed to work out fine. Labels. Now, labels tend to get overlooked, or the application of the labels. So there's a couple orientations here. You have the flat, which goes on a pouch. Then you see the wraparound labels that go on cartons. We ended up making a play to put a wraparound label on a corrugated shipper. And this was back in my senior engineer days. And I said, okay, that shouldn't be a problem. Labels going to adhere to the corrugated. Well, the awesome news was we had an FDA audit going on, and somebody brought me into the warehouse, and all these labels were kind of flipping back. They call it like the spring back motion because of the material. It wasn't enough real estate to stick. And the adhesive with the corrugated wasn't strong enough. So I had to go back. I revalidated everything with a stronger adhesive. So you always want to keep that in the back of your head too. Sterilization. Why do we do multiple sterilization cycles, right? We consider it worst case, but there's two ways why we do that. Is one, it is worst case. So if you do 2 ETO cycles, the other one is if you just do 1 ETO cycle, and let's say this happens all the time, you go through the ETO sterilizer, you either get a short cycle, half cycle, something happens where it shuts down. If it's not qualified for 2X, you're scrapping the entire load that was made in there. So that's a lot of dollars. So that's why it's better to do it in the beginning. And that's pretty much why we would do 2X. You can still do 1X. It just means you can't reprocess it if there happens to be an issue with the sterilizer. The other one, let's take gamma radiation. I used to do gamma radiation back in the day. And if you have your range 20 to 25 kilograms, what you would say is for your worst case, you would radiate at a minimum of the higher end. So you'd radiate the minimum of 25 kilograms. So that would be considered worst case. Climatic conditioning, we subject our test samples to temperature extremes. Take a look at ASTM D4332. I think there's about 4 or 5 different temperature extremes between cold and hot. So you want to use that as well. Also keep note that you don't want to go into shock. So a lot of things with trays is what people do is they'll put them into cold and then they'll put them into hot right away. And then as it goes through testing, they'll crack. So that, that's thermal shock right there. So you want to be mindful of that as you go through this. Simulated distribution testing, right? We simulate the worst case. Subject test sample. So ISO 11607 Part 1, I think it's Annex B, has a whole list of acknowledged or recognized test standards you want to use. So the only 2 that we are recognized right now, at least specifically for what we do, there's a few other ones in there, is we focus on ISTA 3A or ASTM D4169. I'm pretty much a fan of D4169. They're very similar in approach, slightly different. Okay, so worst case configuration. So usability evaluation for aseptic presentation. What is this? This is mainly your design validation, or you're addressing your customer requirements, not the engineering requirements you would do through verification testing. So you want to document the evaluation. You want to demonstrate that sterile contents can be aseptically removed, because the last thing you want is having somebody in an OR, they take out a whole thing in the tray, they can't tear open the tray, the Tyvek's ripping, or they remove a device and the device falls on the ground. That's a further patient surgery delay there. So that wouldn't be good. It allows you to group them by product families, and families based on worst case considerations. You know, all else is equal, like the packaging, the sterile barrier system, the way they remove it. Maybe from the medical device standpoint, use the most challenging content, such as the heaviest ones, the ones with the most components. So you can see how they remove it. Like with the tray, they peel open the Tyvek and they dump it onto a sterile field. The sterile barrier system, you know, those are going to be produced with nominal processing conditions, because at the end of the day, when product goes out, it's done under manufacturing conditions. Same with like stability. You want to seal using your nominal sealing process conditions. You want to ensure that the sterile barrier system can also be peeled open without issue and without the use of tools. The packaging configuration. So again, the most challenging contents, even though everybody's typically focused, you know, on the sterile barrier system device, you know, go for the most challenging contents just to cover your bases. I like to throw that in for good measure. So 1-pack, 4-pack, not necessarily you need to, but I kind of consider it best practice. Okay, so packaging process validation for your OQ and your PQ provides the sealing process window, which is going to determine which set of inputs equates to those weaker field strength outputs we talked about. So in this, you know, we touched briefly on this. You want to use the most challenging contents when you do this. You could have multiple, like the picture below, multiple sharp devices in this that would affect your sealing process. Maybe it hits the backstop of the sealer, it's interfering with your seal, it's puncturing your seal. Those are things you want to assess and take a look at, and be evaluated to worst case scenarios. So typically when I go through process validations, you want to take into account like idling equipment, shift changes, power outages, operator breaks. All this stuff is documented on attachments that go into your report, because again, like I said earlier, if you didn't document the times you did X, Y, and Z, probably never happened, right? You need to prove that out to an auditor. So I got a couple examples I like to finish off with that I've used in the past, and I'm sure there's some other good ones out there too. So the one at package performance testing, right? You know, here's some assumptions of basically the sterile barrier system and protective packaging designed to contain 4 types of similar devices in the product family are identical. So similar, identical packaging there. So the assessment is each device model is similar in geometry and contact points. The only difference between each device are the catheter diameters and lengths. Therefore, the largest 29mm catheter will be used as a representative device. The 29 catheter is the most challenging for package verification testing as it has the most mass and largest geometry as it relates to the sterile barrier system. And the 20, 23, and 26mm catheters will be considered validated under the successful completion of this test protocol. So it's very high level. I would probably also include some pictures in there just to show, and maybe a table to show what the similarities are for an auditor, because auditors love pictures, auditors love tables, based on my previous experience. And then in example 2 for process validation. So some assumptions for this. There are 29 variations of the same pouch, meaning materials all the same, but the length and the width dimensions are different. The seal width is identical. Let's just call it 3/8 of an inch to seal width across the board. The contents do not affect the geometry of the seal during the process. And there are 4 families of devices that will use this pouch, similar in geometry, that don't contact the seal area due to pouch head space. So what's my assessment or example of this would be, all right, so for the sealing process validation, the following family of devices were evaluated. You have a 20, 23, 26, 29mm catheter. Catheters are secured to an HDPE backing card and placed into the pouches. However, they do not affect the sealing process or contact the seal to affect its geometry. Therefore, the contents are not required to be used for the execution of this process validation. Again, this is where I would use a lot of pictures to put in here to show how it's processed and how it doesn't contact the seal, because there's a lot more headspace in that pouch. And then when it goes into the protective packaging, it's kind of rolled or folded over into that, so it would never contact the seal. Pouch part number XYZ will be used as representative pouch out of the 29 pouch part numbers, as it has the longest made manufacturer and seal. The longer the seal, the higher for the potential for variability in seal strength. Therefore, seal test samples will be, and randomly is very important here because you're telling the auditor what you're doing. You're pulling test samples at a random pace along the length of the MDM seal and evaluated. All other pouches will be justified under the worst case pouch being tested. There's one more I'd like to throw in here that I didn't list. Let's take stability testing, going back to this one where I had 29 different pouches. Again, we had two worst case ones. We had, in this case, we had the longest seal because it was, let's say, 20 inches wide, but we also had a pouch that was 69 inches long for stability testing. So we used both, and part of my assessment there was, instead of testing everything, because again, we're managing our resources wisely in this case, is the longer the MDM seal is, the more worst case it is for variability and peel strength. So randomly take a sample from that. And then from attribute data like submersion leak testing and dye penetration testing, we use the longest pouch because that had the higher surface area. So again, the largest surface area could lead to the most potential for a sterile barrier breach. And that worked through getting IDE approval, CE mark approval, PMA approval for new product on the market at the time. So just some references where I kind of pulled all the information from. Again, Liz Nelson wrote this white paper, which Renee will send out after, along with the slide deck, on sterile barrier packaging systems, worst case assessment for performance testing. And then, as you know, we got ISO 11607 Part 1 and Part 2, the 2019 version. And then also, I highly recommend you take a look at the technical spec guide 16775. It's still 2006. They haven't updated yet to align with 2019, but it gives you a lot of great guidance on how to apply what ISO's Part 1 and Part 2 are telling us to do. So I think with that, we'll take some questions.
All right. Ooh, sorry, Lon. There's a I can hear an echo. Thank you. Oh, okay, there we go. It's better. Okay, so you have a ton of really great questions. One was a comment, and it was good words of wisdom. And I think that came back to what one of your previous mentors had said around, if you don't record it, it didn't happen, or some to that effect. So anyway, great words of wisdom there. And then also, just in general, sorry, I got caught off guard with the echo. Great job on the presentation itself. This thing looks great. You have me on camera. Go ahead and get me off. Thanks. So, question. Example, test was qualified with universal IFU heaviest. What if we remove the IFU, replacing it with the EIFU? This will create more space in the package. Should it be tested again without the IFU? You'll need to unmute yourself, by the way.
Yeah, that is a great question. So really you need to kind of evaluate and assess that, because we are trying to move more to an EIFU and not ship paper, right? So if there's more headspace, and what I like to do in the design piece of it is reduce the amount of transversal movement within the carton, right? Because the more movement you have, the higher potential you have for abrasion, which causes particulates that can get put onto the device, inserted into the patient. We look for that, right? Also, the abrasion could start leading to cracking or pinholing, which would be a failure to maintain sterile barrier integrity. So what I would recommend is like, take a look and really see like how it's placed in there, see how much headspace you have. If you feel you can't make a rock solid technical justification on why you don't need to revalidate it, then it's probably a good idea to go ahead and revalidate that. So you really have to kind of look at all your options there and evaluate them.
Okay, the next one is specifically refers to the low process parameters, OQ low. Do you feel it's true for shelf life as well, or just performance testing?
Another great question. So as we all know, performance testing and stability testing are separate entities. Performance testing evaluates the stresses imposed through distribution, climatic conditioning, processing, T equals 0, right? So if you demonstrate that successfully, and you also have your specs, you have your minimum peel spec, you have your seal width, visual inspection, that sort of thing. Stability is a time-related event. You don't need contents for that. And this comes into that whole resource management. And it also, even if you look at ISO 11607 Part 1 under Section 8, it goes into a note about this. Being a time-related event, essentially all you're going to do is seal at nominal conditions, because that's what product gets sent out to the end user. That's what they see. When you do production, they never set a sealer at the low end or the high end. It's always at nominal with the alarm range. So when you go through and set up your stability samples, if the contents don't affect the geometry of the seal, and I've done this many a times, you write the justification in there, and I basically seal up empty pouches, put them in the protective packaging, and they go sit either in an accelerated aging chamber for X amount of days, or they go sit in a controlled monitor warehouse for X amount of days. And then what we do afterwards is go through and do visual inspections. We go through and do dye and leak testing to prove out sterility, but we also look at the specs. So we compare the peel test data. So let's take the peel test data. You would compare the peel test data at aging, and as long as it didn't fall at or below what you already have existed validated for T equals 0, then there should be no issue, because it shows that time has no effect, or it won't have an effect on what you've already done, meaning that you've already proven out effectively that your package design maintains sterile barrier integrity through worst case conditioning. And then you've already proven out that as a time-related event through stability testing, that your specs don't fall below what you already have validated through shipping. Hopefully that made sense.
If you use low or below low seal process settings, how do you deal with possible non-acceptable visual transfer or even below acceptable seal peel strength values?
Good question. So what I've done in the past is you want to do feasibility. You just don't want to create a set of parameters and just go into a validation or verification study with it, right? We're spending a lot of time and money on this. So do a lot of feasibility. I used to go into and just go straight to a package verification study, and then lo and behold, we got failures. And I'm like, okay. So I came back and designed some feasibility testing around this. So if you're going to create a set of DV low inputs that equate to a super weak peel strength, highly recommend create some samples, put it through worst case testing. What I used to do with ASTM D4169 is do that, but 3 times over. So if it was, example, if you did drop testing and it was a 12-inch drop height, I would double it or triple it. I would go through one complete round of DC 13, distribution cycle 13, under, worst case with those weaker parameters. The idea is to get a failure, if you can get a failure, because you want to mitigate that risk prior to going into a verification study. And that gives you a higher confidence going into that study. So you definitely want to do some homework upfront before you just go ahead and implement those.
All right. On slide 14, what does DV stand for? Oh, you're on mute.
Sorry. Okay, so I just want to use a set of parameters that I'm just calling design verification parameters as my DV low, as you can see here. So that's all I named it. That's what that means.
All right. A quick comment. Good job to both you and Liz. Liz for providing all the background for this presentation, and you for presenting it. So a quick kudos there. Next question. Anything done specifically for last mile?
Let's see. I think I'm guessing last mile, meaning prior to going into your verification study, is what my assumption is. So what I would do, again, it goes back to feasibility study. As long as you can go ahead and go into your last mile or verification study with a very high confidence and reliability that you're going to pass, that means you did all the due diligence and homework up front. Whether it's your weaker peel strengths, it's your process sealing window, you dotted all your I's and crossed all your T's for this.
Quick time check. We only have about 5 more minutes and we have quite a bit to still get through. So 11607-1, section 4.2.2 specifies testing with the worst case protective packaging. How is this defined for components such as tip protection over sharp device features? What about shelf cartons and shipping containers if they may be considered protective packaging as well?
That's a tricky one. I got to think about that one. If you go into the standard and you go into TS 16775, it really gives you a lot of guidance on protective packaging. So let's say tip protectors. Let's take that for instance. You know, if you're packaging blades or sharp medical devices, you want to. That's part of what you're going to be selling to the end user, right? So you want to make sure it's reflective of that. So I would use those. There's been instances where I've had, I found through feasibility testing on these used to work with 69-inch long catheters that go to your heart. And what would happen is I noticed the handle would cause some abrasion on the pouch and there'd be particulates all over. So I would actually use a backing card. They're really easy to use and update your design versus, let's say, a mold for a tray to make some changes there. And create like these tabs that would actually cover certain parts of the device to mitigate the risk of puncturing the sterile barrier system. You know, same with the carton and the shipper. Really, you know, the shipper at 200 pound, 275 pound, you'll be fine. The shipper is meant to take the brunt of the forces. You can tell when you go through drop testing, it looks buckling in all the edges and all the corners, but that's really what the shipper and the carton are for. At the end of the day, they remove the carton and it could have some buckling, but again, that's still considered protective packaging. So hopefully that answered your question. I would strongly recommend take a look at the guidance in 16775. There's probably a little more information there too.
All right, next up, if you compare tensile strength sterilized from new ETO cycle and current ETO cycle, what would you take into consideration into worst case Tyvek blister? Big blister, large sealing surface, or small versus large product, etc.?
That's an interesting question. So I've done things in the past where we switched sterilization cycles and things were done worst case with cycle A. I actually had to go through line by line, and we'll take ETO on the ETO sterilization and demonstrate how this new cycle is not as any worse case than what we've already successfully evaluated everything under. So it's a very intensive thing that you need to do, and it needs to be very technical. You're looking at every aspect, but as you know, as you go through the ETO sterilization phase, what really does it do? Because you have breathable material Tyvek, so what it's going to do, it's going to stress your seals. So you have time, pressure, moisture, there's a vacuum pull on it. Really what that is stressing your seals, and the material is the vacuum kind of pulls and then it expands and it aerates from that. So, you know, from that standpoint, when you go into changing your packaging, if I understood the question correctly, you're going to have to go back and probably requalify your sterilizer with a new package. And that should be done anyways to prove out the safety and efficacy, you know, through external process challenge devices, internal process challenge devices. You have to look at your overall package product density, make sure it doesn't exceed what the chamber's already validated for. So it's not a simple answer, but there's a lot of attributes you have to really evaluate and look at to make sure.
Okay. Can you mute for a second? Why do you prefer D4169 versus ISTA 3A?
Well, I think before ISTA was not really democratically voted on. I think people provided ideas in regards to ISTA, and it was really for, you know, I think when it came to Schedule J, which is like dropping the dart on the corrugated shipper and really just saying that, okay, if you have 275-pound shipper, you don't have to do it, but if you have a 200-pound shipper, you have to do it. I don't know. I just felt like it, you know, a lot of the ISTA stuff, and some of it in a sense could be for not overloading a truck versus I commonly used with ASTM. It's a democratic voted standard, so you get a wider range of everybody agreeing on what goes in there. And maybe that's changed for ISTA too. I really can't answer that accurately, but I prefer ASTM versus ISTA. Although they're both recognized by ISO 11607, so you could use one or the other.
All right, this next one I'm going to combine because they all revolve around the same topic, which is around climate conditioning. So with that, do you send a sample through all three main conditions, freezing, hot, humid, desert, or do you only choose one? You mentioned shock, How do you mitigate this if your product has a chance of seeing all of the conditions? And then the second part, tandemly, do you test right after the temperature extremes, or do you let your packaging come back?
Great question. And I've seen this time and time again where I do everything in one shot. So typically what I've done is use negative 18 degrees, and this is under ASTM D4332. And then I believe worst case was the humidity. So then we use tropical, which is 40 degrees C at 90% relative humidity. So what I always stated in there, and if you look at 4332, it says if you don't really specify duration, it defaults to 72 hours. If you know what the equilibrium is in the chamber, you can reduce that. So I highly recommend that piece. But what I've done in the past is specify and say, okay, you're going to sit your samples out in ambient lab conditions for, let's say, 4 hours. Then I'm going to stick them in a chamber at negative 18 degrees because I knew equilibrium was reached under 8 hours, and just said for a minimum of 8 hours. After that, come out to ambient laboratory temperature for 4 hours, put it back into the other extreme, 40 degrees C at 90% RH for another 8 hours. And then before I go through and do all the distribution hazard simulation testing, I let them get acclimated to 4 hours and then go through all the testing. This kind of avoids that thermal shock that we're talking about, because I've seen it before with PET-G trays where you get these temperature extremes, you go into one temperature extreme, take it out, immediately put into another. So you're kind of asking for failures. Also, the logic behind it is it really going to see that big of a temperature extreme when you ship product out, right? And we've been shipping out product for, decades. I don't know how long you've been using this method, but that's kind of the approach that I take for it. And again, I've submitted all these reports and documents and defended them in front of auditors, through IDE, CE mark, and PMA submissions. And there was never any question around how I did that, but you also want to explain that in your protocol.
Okay, for taking peel samples during PQ, you advocated random locations. Why not take 1/3 from left, 1/3 from center, and 1/3 from right? Are both approaches valid?
Yeah, you can do it any way you want. I like to say just randomly take a peel sample from, let's take the MDM seal, our final seal. I just say randomly take a sample along that. The other piece of this is, as you go through your process validation, this is why it's very important to do your thermal process mapping on a sealer with the thermocouples. So you know across the bar that you're getting pretty much the same heat or consistency across that bar. So that'll help you too prior to going into it. So you could take 3, you could take one toward each end, you could take one in the middle, you can combine all the data. But as you really go through and you look at all this data, you're looking for reproducibility and repeatability. So in between each PQ run and across all 3 PQ runs. So you're gonna have a lot of data to statistically analyze to demonstrate this.
Okay, and then last question. Talking in percentages, how much affect the ETO at seal strength? If pre-sterile you have average 1.8, how much percentage could be reduced?
That is a very great question, and I don't have the information for that one. So I think what I would say it's going to vary, and it really just depends on the processing. Every ETO cycle is different, so you could set up a study and kind of demonstrate that, as you go through all your testing to do that. But I can't really explain, what the percentage. It could typically, what I've seen in the past is after you sterilize something, it drops off a little bit, and then over time it kind of increases, hits a plateau, and then it decreases, which is why you go through performance and stability testing, and then you test samples in that same manner.
All right, awesome. So this is going to conclude our presentation today, and we want to thank everyone for your participation, and your great questions during this Brunch and Learn. Again, you'll receive this recorded presentation, the PDF of the PowerPoint, as well as the white paper resource, Sterile Barrier Packaging Systems Worst Case Assessment for Performance Testing. Make sure you stay in the loop and be sure to follow Network Partners on LinkedIn to access our updates and our future webinars. Thank you again, and have a great rest of your Thursday, everybody.
Thank you. Thank you. Bye.